The world was gripped by the dramatic recovery of a container ship that became lodged in the Suez Canal, the transit for about 15% of global shipping traffic. The Ever Given was stuck on the channel for almost a week, causing a huge build-up of vessels around the waterway. Refloating the Ever Given was a monumental challenge, and it all came down to physics, says Peter Badowski, the CEO of Boskalis. Boskalis owns the Dutch firm Smit Salvage, which assisted in dislodging the ship.
It's all about physics, and most physical laws are not that difficult, you could say. But the trick is to make them work for you and not against you, and that's what we did.
The 430-yard-long ship was jammed diagonally across the southernmost stretch of the canal. At least 8 tugboats were used to push and pull it away from the banks, with the help of the ship's own winches. Diggers cleared earth at the ship's bow, and 2 dredgers were deployed. Dredging sand surrounding the vessel only had a minor impact. Sources said ballast water, which is used to help stabilise ships, was offloaded too, amid efforts to refloat the ship.
We had a plan B involving water injection under the vessel, because with the digger, you can scrap a little bit of soil around the vessel, but not under the vessel. The same holds for the cutter dredger they used. So again, you dig some soil away beside the vessel, but not under. So what we more or less did is we used the water power that was in the canal with the returning tide to push the vessel where we were pulling it. And the combination of the two, as we hoped, at the end of the day did the trick.
Smit Salvage has been involved in high-profile rescues before. It assisted with the Costa Concordia disaster in 2012 and raised the car carrier Baltic Ice in 2015 after it sank near the port of Rotterdam. Location in this instance was a major factor. It took nearly a week to loosen the vessel. The delay was down to waiting for 2 tow vessels that were heavy enough, rare in the region, to reach the site.
The most important characteristics of the environment is that it's in relative isolation. Like if something like this happens at the port of Antwerp or the port of Rotterdam, where we've done these jobs, you have vessels just around the corner. You have crane vessels even around the corner. There are so many possibilities you can use, so you can optimize plan A, B, C, D up until Z, so to speak. So the difficulty is you're really in the middle of nowhere, stuck with a vessel and no equipment nearby. So that's the big challenge, really.